I'm going to draw in the same colors, the same situation, but in this different graph. So again, we have a y-axis and an x-axis. And our x-axis, again, is going to be time. So we still have time, it can still be in seconds. And let's do 0, 2, 4, 6, 8, 10 seconds. But now our y-axis is going to be speed or velocity in meters per second. Remember that the unit for speed or for velocity is meters per second. So we can have 0 meters per second. Let's say this is 1, 2, 3, and 4 meters per second. Okay, so our first line, the red one, was at rest. That means that the object is not moving. If the object is not moving, it makes sense that its speed is 0, because if its speed was anything other than 0, it would of course be moving. So to replicate this line, but in a speed time graph, we draw a horizontal line, but now not where the object is, but at the speed of the object, which is 0 meters per second, the whole time. So we basically draw a line on top of our x-axis. Sorry, it's so wiggly, but this line is at rest, the object at rest, because it has no speed since it's not moving. That's the first case. Now we had two that were constant speed. One was slower and the other one was faster. And we had actually calculated the speeds of each one. So in the first case, we had a speed of 1 meter per second. And the speed was constant, the speed was not changing. So we're going to have a straight line again, but now at 1 meter per second. So basically for the whole 10 seconds, the object was moving at a constant speed of 1 meter per second. So we're going to have a horizontal line, while here we had an inclined line. Here in the speed time graph or in the velocity time graph, we have a horizontal line at the speed of the object. Now, the second example, which is faster, is also a constant speed. So it's also going to be a horizontal line, but this time at 2 meters per second. So it's going to look something like this. Right? So this is at rest, and these two are constant speeds. Speed is not changing. And finally, we have our acceleration. So when there is acceleration or deceleration, speed is changing. As we said before, acceleration is the rate of change of speed. So it is changing. So in this case, maybe the speed was getting faster and faster until it got to 4 meters per second. That's a possibility. So it started at 0, it became faster and faster, and at the end it was moving at 4 meters per second. So we're going to have a speed of 0 at the beginning and a speed of 4 at the end, which means our line is going to look something like this. So notice that if we have an inclined line here, we have a horizontal line there. And if we have a curve here, we have an inclined line there. Now what about deceleration? Deceleration was 4 at the beginning and it became 0 at the end, the speed. So we're going to have the opposite. We're going to have a line that goes down like this, right? So it's a speed that is fast and gets slower. So going down on this graph means getting slower. Going down on this graph means coming back home. So it's always really important to look at what is in your axis, distance or speed, because the same line, for example, this orange one and this blue one look the same, but here it means slow constant speed, and here it means acceleration. So let me label that so that you guys have that too. So this one we said was at rest. At rest when speed is 0. This is slow, constant speed, which is the speed of 1 meter per second. This is fast, constant speed at 2 meters per second. And the higher the line is, the faster the speed. This line that is going up is accelerating. And this line that is going down is decelerating. Right, so there we have our 5 examples that we put here, but in a speed time graph.